Welcome students for this another session of digital switching systems, that is a maintenance of digital switching system, that is strategy for improving software quality. So far in the last session, just to brief, we focused much on the different maintenance metrics, like how many patches we applied, how many diagnostic resolutions we did, like that. Some of the 4 or 5 we took an example and explained about that. So those are the matrices, or you can say performance parameters of what the work or the maintenance we are doing. So by that those numbers, maybe percentages or sometimes simply numbers, will tell us about how well the maintenance is going on. So next, to continue with that, so we now have to adopt some strategy or approach for a continuous improvement of the software quality. So why only software quality? Because the DSS software what we are using is a genuine one, generic one, and it should be because the DSS should work 24/7. That is a real-time system. It should not be hampered for this or that reason. So that's why patches concept also we have studied. So in that case we have seen how the patches are applied without hampering the system function or DSS system function. So today we can see, so uh, sorry, the this one, strategy for improving software quality. So here you can see strategy for improving DSS software quality is as shown in this figure. You can see it is based on the process metrics defect. These are the process blocks are there, and defect analysis the main basis, the block you can say, and another one is a continuous improvement program, CIP block here. All these blocks are interconnected with the help of this field problems and outages block and customers feedback. Okay, so if you look at these things, so how to explain about this? So I want you to listen on this one my video, because nowhere you will get any explanation about this, neither in notes nor in the book, Sayed Ali book, that we are referring module 5 for this purpose. So this is a very important point we are covering today, students. So please listen to me how to explain about this. So basically we'll get a question something like discuss or short note on strategy for improving the software quality for the in case of the maintenance of DSS, like that. Okay, you need to draw this block diagram for this purpose, and next we'll see how to explain about this. As usual, two sentences will be remaining same as it has been shown here. Strategy for improving DSS software quality is as shown in this figure, and it is based on the process matrix, defect analysis, and CIP. You can tell it is visible, you can just copy and write that. Okay, but how to continue with this and how to write the answer for this? So first of all, whenever you draw the block diagram, you try to brief about that. Okay, you try to brief about that. So listen how to explain about this. You have to draw this block diagram and let us see how to explain about this. If you want, you can write these two sentences, then later we can include my summaries. Figure shows the simplified block diagram for the strategy for improving software quality in a TSS. Okay, maintenance of the TSS, like that you tell. It mainly consists of 3 subsections, like program for software process improvement, a set of software processes in the middle, the defect analysis at the bottom. So these are the 3 main sections which are interconnected or interconnected by the feedback with the help of field problems and outages and customer satisfaction metrics. So like that we have to brief about that. And then later we can tell, let us see how to explain about them, each of these blocks, what are their functions and how they are interrelated with each other. So I just told there are 3 subsections, 3 main sections: CIP, a set of processes, and defect analysis. These are the 3 main sections of this block diagram. To start with, first of all, see how we can look at these processes. Okay, so the arrow mark, if you see, So let us see how many types of processes he has mentioned in the block diagram. Software development process is there. Here also software development process and its related matrix. Software testing process and its related matrix. Software deployment process and its related matrix. Software maintenance process and its related matrix. So let us see what we mean by software development. Before going in deep about each of these process, so let us see each of these processes are directly getting the input from the defect analysis. Okay, defect analysis is nothing but it will contain the fault reports. Okay, fault in the previous some of the slides we have seen, no, fault reports or trouble reports, it will be there, and those reports will be generated with the help of the field problems and outages. Okay, means how well we identified the problems or faults in the fields. Okay, and outages we addressed, and how long we have took the time to maintain them. So all those things are now coming here as a feedback or input to defect analysis in the form of report, and now that will be given based on that as input to these four types of the processes. Remember, there are four main types of the processes which are working in the heart of this strategy for improving software quality. So these arrow marks will tell that the inputs what we are getting for these processes are coming from the defect analysis. This is how it is coming. Okay. So where the inputs are going, also inputs are also going to the customer satisfaction matrix from the field problems and outages. That is going to set the threshold for the next further software process improvement. Now coming to this one, each software process here, for example, software development process having a bidirectional connection with the software development matrix. Its corresponding matrix. Matrix means software development process is there, and how well you are going to work this, it's that can be assessed with help of some performance parameters. Matrix means performance parameters related to software development. So those based on that performance parameters which have the bidirectional link with this process, we can set the threshold and objectives. Threshold you can set, and how much to what extent you achieved, that will be applied to the CIP, and that CIP once again will recollect the thresholds and will assess to what extent the thresholds have been achieved, and it will revise the objectives and given as feedback input back to the matrix. And this is same thing is copied to all of the respective software processes matrix. Okay, so software testing process also you can see it is having its own performance parameters in the form of software testing matrix, and its threshold will be set, and whether it is achieved or not, to what extent it is achieved, it is assessed with the help of CIP, and again new revised objectives will be set or given as feedback to the matrix. Similarly, software deployment process having its own performance matrix. Threshold will be assessed whether it is achieved the threshold up to the mark or not, and revised objectives will be given as feedback to this. Similarly for the software maintenance process. And remember, there is a bidirectional communication between each of the process with its respective matrix blocks, and each matrix block has got its own threshold to be achieved and revised objectives getting from the respectively getting from the CIP. Okay. Apart from that, you can see in the block diagram it is also visible. Each of these processes have input in a systematic fashion. Inputs are something like that. First, software development process, so it is giving certain kind of feedback or inputs to the testing process. Then its input will be given to the deployment process, then to the maintenance process, then its output will be given as input to these things. Why? You can see for that to understand, we have to deeply understand the functioning of each of these processes here. Okay, software development process means, just I will brief out here, later we are going to study in detail in the further slides in the next some of the sessions. Software development process means, for example, we are going to develop some of the modules or some new features we are going to add here. Okay, and based on the defect analysis, because it is getting the inputs from the defect analysis, based on that we are going to revise some of the features, means we are developing some of the software here. Okay, so what is happening here is that version, if you are going to add more features, version of the software is going to change, its upgradation is required if you are going to deploy it in the market. But before deploying that software with a new version with the new features, you have to test it. Okay, with the new features you have to test it here. After that only, if it is successful, it will be deployed. Then software maintenance process, once it is deployed, no, to what extent it will be maintained, whether it is maintainable or not, if it is once released in the market, and what are the problems which are now coming there in the field problems and outages. Same thing will be given as feedback to defect analysis. Once again, you can see here there is a closed feedback loop between all these processes and the defect analysis and these field problems and outage blocks. You can see there is a closed feedback. Okay, there is a closed feedback coming, circulating between the all process, field problems and defect analysis. Same as input given to customer satisfaction matrix, that is going to set the threshold to what extent the customer's problems will be addressed, and given as threshold input to the CIP. Okay, again its revised objectives are coming back from the CIP through matrix, through processor to through field problems to customer satisfaction. Again, it is a, you can see it is a closed loop like this. With the closed loop we are getting like this here. So two closed loops are there. One closed loop between the process defect analysis and field problems. This one closed loop in the clockwise direction. Another closed loop is there between the processes field problems matrix CIP. Processes field problems matrix CIP, like this, anti-clockwise. Like that, you have to summarize the answer with these three sections and two main loops which are happening here in this block diagram. Okay, now what CIP is doing here? So CIP, you can see all the way it is getting the thresholds from each of the matrices, performance parameters. Okay, so it is going to assess whether the respective thresholds are achieved or not, and with particular objectives. If not, the objectives will be revised and fed back to their respective matrix blocks and respective process blocks. Again, with the second loop feedback, the processes will be updated, their work will be updated. Like that, it is a continuous improvement program. That's why the top block, you can see it is given as a program for software process improvement. There should be a continuous improvement, because DSS software is generic, it should update with respect to the new real-time problems or features. Okay, so hope you understood this one, how you can explain about this. So students, don't be panic, it is very simple. You listen to the video again and again and try to summarize the answers in your own sentences. That is important. So draw the block diagram, brief about it with three important sections with feedback elements. These two are feedback elements. How they are related, you just simply tell in 1, 2, 3 sentences. And after that, you tell about, starting with the heart of this strategy for improving software quality, that is about the processes. Tell about their connectivity, that is itself is going to explain their links and relationship with their corresponding blocks. So tell about the process, the corresponding metrics, their corresponding threshold and objectives, how they got revised by the top block. Okay, and how they got connected horizontally. While doing so, explaining so, you tell about briefly the functioning of each of these processes a little bit in detail. And finally, you can conclude with this one feedback loop in the clockwise direction, bottom feedback loop, and another top feedback loop in the anti-clockwise direction. So that is going to complete your the total continuous improvement program for the DSS software. So then why this one is required now? We'll go for next one, program for software process improvement. Why actually it is required? So software processes for the DSS are usually large, they are generic, and they should be updated in real-time basis. they should be usually large. They should be complex. They are complex and multi-locational because they spread geographically. They multi-locational with respect to different location of the local exchange office or common offices. Okay. So these processes must be formalized or documented. So this is very important, students. Formalized or documented means they should be properly documented. We cannot simply telling this in sentence that DSS are large. Large means it means here how to what extent the software processes are large here. The last slide you have seen 4 important processes we discussed. Each process is now telling it is very large, complex and multi-locational because it should operate from different geographical regions and baselined by putting them under configuration management system. So we need one configuration management system to formalize and document them and to maintain them remotely or manually without hampering the working of this DSS real-time system. Why? So this will allow the tracking of any changes to the process. Okay, processes have to be updated because you have seen in the last slide, defect analysis is continuously giving the feedback inputs for the further updation of the respective processes, and there is a closed feedback loop between the all 4 processes, outages and defect analysis in a clockwise direction that we have discussed in the last slide, and help the process administrator to better understand the impact. Impact means what here? The impact of the customer service, that's all. What customers actually want, whether their problems are properly addressed or not. So by this only we can ensure that the service of the real-time DSS is 100% sure. It is reaching the or meeting the customer problems, servicing the problems. So this will give rise to the continuous, you can say, improvement process. So process change does not always improve the process, but a continuous improvement program always does. Means what is telling? So updating the process doesn't mean that it is a CIP, but continuous improvement program always does. The top block you have seen, no? So that top block itself is mainly held responsible for the continuous updation or upgradation or improvement of each of these processes. That's what we mean by the concept of CIT here. CIP, sorry. So if you look at these things, so the strategy here is CIP strategy, what this could be. So the CIP can vary greatly from different processes because you have seen 4 different processes, each process having its own distinct or unique function is there, process and products. So strategy is going to be different. So it could be something like some assumptions are there like this. For at this level it is just based on assumption we can think of how we can achieve this CIP strategy at each of the process level. The processes can be instrumented. Means if suppose for example software development process is there, or software testing process is there, software maintenance process is there, software deployment process, 4 processes are there. Okay, so in order to ensure that how they are improving, we have to instrument it. Metrics are there, but who is going to measure it? Performance parameters are there. Who is going to measure the performance of each of these processes? For that we need instrumentation, either in the form of hardware or software for each of these processes. That what we mean by the processes can be instrumented. The inputs to the improvement process are the thresholds, we know that one, established for the different metrics. So each process has its own unique threshold and unique metrics. Based on that, its objectives will be decided and thresholds will be decided. It doesn't mean that all the processes should have the same threshold and same performance parameters and objectives. They will vary based on the functioning of each or duties of each of the processes. Okay, so these thresholds are used. So remember here, these thresholds are used to observe the impact of changes on all processes. To what extent these thresholds or objectives are met by each of these processes will be having a significant impact on its corresponding or adjacent processes activity. Hence, a group of new thresholds upgradation for continuously to improve the quality of software process is now established. By this, we can able to establish the new threshold that you are observing now, the last figure. Finally, we are getting one final threshold from the customer satisfaction parameters that will be established. Okay, so this how you can explain up to till this one, the CIP continuous improvement program software strategy up to this one. Will now stop.